I'll do this too.
No, thanks. Okay, this is our very basic design of a mousetrap car. As you can see, we chose to design it in a very simple and elaborate way. We used cardboard, CDs, duct tape, skewers, and yarn.
Firstly, we chose CDs because they have good traction with the ground and with the axles. If these two aren't present, then the whole purpose of the car is eliminated.
Secondly, we chose cardboard for the base of the car because it's not too heavy to weigh down the car, yet it also is thick enough to hold the car together. Next, we have skewers at the axles because they don't cause friction between the dowel rods and the skewer.
Duct tape is useful for one very sticky, which holds the piece of cardboard together very well. It also keeps the CD spinning with the axles very well. As you can see here, we ran string along the bottom, and you spin up the rear axle to where it catches and triggers the rear axle.
Lastly, we chose yarn to be the material that transfers the potential energy from the spring to the rear axle. Yarn is the best because it wraps around the axle, whereas fishing line and ribbon don't wrap around the axle.
We tried to limit the amount of friction as possible by having the wheels not touching the base when we launch the car. The CDs have very little friction with the ground, yet enough to have traction. The friction with the skewers going through the duct tape on the CD make the CDs turn while the axle does also.
Traction is probably one of the more important things involved with the car because if it's not present, the car won't move no matter how good everything else performs.
Newton's first law applies to the car because an object will remain at rest unless acted on by an unbalanced force. An object in motion will remain in motion unless acted upon by an unbalanced force also, that friction being in this case.
So we try to make our car as light as possible because the bigger the mass, the more force will be needed to accelerate the car, which the mousetrap is not that powerful.
When the car goes, the force is forward, but the ground is pushing in the opposite direction just as hard, causing the car to go forward. The best place to see that is when a car kicks up a dirt.
The work Ft cosine theta is determined by the force which comes from the spring pulled back on the trap and the distance the car travels. So if you want to figure out how much work is done, just plug it into the equation.
The transfer of energy happens from the potential energy stored up in the string. Once you hit the trap, the energy goes through the string, which unwinds the axle and which turns the rear wheels, making the car go forward, and thus turning all that potential energy into kinetic energy.
And that is the conclusion of our mousetrap video.
And she smiles.